Welcome everyone. So in this session we are going to solve a problem which is remove duplicates from sorted array. Let's try to understand the problem statement. So you are given a sorted array. Let's the example be nums equal to 0 0 1 1 1 2 2 3 3 4. So total there is 1 2 3 4 5 6 7 8 9 10 elements are there and it is sorted. What you are supposed to do is that you should manipulate this particular array in such a way that nums equal to 0 1 2 3 4. What we have done here is that we have removed the duplicate elements, and whatever the elements exist, that will be shown at the initial part of this manipulated array, and the remaining can be anything. So remaining can be anything, it doesn't matter. And you are supposed to return the length of these unique elements. This particular length is 0 1 1 2 3 4 5. So 5 is the number you need to return after manipulating nums in this particular fashion. I hope you understood the problem statement. I can give you a simple example also. If nums was something like 1 1 2, then it would have been manipulated into 1 2. That would have removed this duplicate element, and this remaining can be anything, and the length corresponding to this thing is 2. We should have returned 2. So that's a problem statement. How we can do it? So one thing is that you can do it in a brute force manner. I can explain you what is the logic behind the brute force. It's like you just start with a new list. We can name it as unique, and append elements. Those are unique, or those are only ones, like it can be stored only once, like that. That means in this they are stored 0 one time, out of this store 1 one time, out of this store 2 one time, 3 one time, 4 one time, like that you should store. How can we do that? Let's try to solve using coding itself, so that will give you better understanding. So this is the class definition, class solution, and the method inside the class is, let me name it as remove duplicates. Since you understood the problem statement, you can write the arguments inside the method. That would be nums, which is a list of integers. And what else is there? Nothing. What is the return type? Another integer. I'm starting with a new list, unique. Then I'm going to traverse for num in nums. If num not in unique, this means if this particular number has not seen in unique, that means it is something has not appended yet in unique. So that in that case you can just append that particular number. Unique dot append num. So while doing so, this particular new list we created will have these informations, like, since it will not allow the duplicates because of this particular check. And after that we need to manipulate nums like this fashion. For that we have to traverse through the unique for I in range of sorry, this is not the proper syntax. For I in range of length of unique, it was correctly, then nums of I will be replaced by unique of I. But what we actually needed, we needed this particular length. This is nothing but the length of unique array which we have created. So we just need to return length of unique. That's it. So what is the time complexity here? So as you can see here, we are traversing it once, and inside each traverse there is a condition we are checking. We are checking whether that particular element is already present in the unique array or not. This checking is also order of n, and the traversing itself is order of n. So back to back these two actions will create a time complexity of order of n square. So the time complexity here is actually order of n square. Since we are utilizing a new list, the space complexity is order of n. So is there a better solution? Yes, there is. We can try to solve using pointer method. So let me start by taking this example to explain the pointer method. I can simply copy it over here. So what I am going to do is that I am going to start a pointer k from this index, index 1. Since this is sorted, and also I am going to start traverse from I here, I equal to 1, and while this I move forward, I will check whether the elements at I, whether it's equal to or not equal to nums of I minus 1. If this is the case, then I am going to substitute nums of k with nums of I, and I will be pushing k one step ahead. This will move one step ahead and will stand here. If this is not happening, the k will stay there itself and I pointer will move forward at the end. By this way also we are going to manipulate the nums as we want, and the k pointer will actually count those number of unique elements or number of single character that what we wanted that will be returned. So let's try to code it. So let me erase this particular thing which I used to explain. So for that I am going to copy the class definition also, that is repetitive. So let's copy that. Yes, I have copied. And I'm going to start from k equal to 1 for I in range of, I'm going to start from index 1 and I will go up to length of nums. If nums of I not equal to nums of I minus 1, if this is the case, then nums of k will be updated as nums of I, and k will jump one location, and eventually the array will get manipulated as we want. That's it. And we just need to return, at the end we just need to return the k. That will be the count what we wanted. So what is the time complexity here? Here it's simple, we are just traversing it only one time and we got the solution. It's all about fixing two pointers at the exact locations and just doing this kind of an approach. So time complexity here is order of n, and space complexity, since we are not utilizing any extra space, order of 1. So this is a way better solution for this particular problem. So with that, we have explained the problem statement and explained using example shown the brute force and the optimal method. With that, this problem is done. So thank you everyone.